Hey, Sophia. Thanks for being here.
Hey.
Well, I'm a big fan of your work. I've seen some of the stuff you've published and some of the talks you've delivered. Very cool stuff. I was wondering if you could, do a little introduction of yourself and tell us how you got started in cybersecurity and what it is that you do today.
Sure, yeah. So I guess I was always kind of interested in the security aspect, when I was younger, mostly through trying to get free videos and free games and software and stuff like that. Some of that cracking sort of scene. But it really wasn't security in my head. It was more just like something you did on the internet. And so I went to college. I went to school for electrical engineering. And I always liked computer science as well. So I'm like, okay, well, I'll do computer science too. Because I just like programming, it's fun, it's like a little puzzle. And then I went to school and I started hanging out with these guys at school who had been doing security stuff. So they were a team that did capture the flag challenges. And just hanging out with them, I started also doing capture the flag as well. And so over the course of my 4 years, I went to school at Rensselaer Polytechnic, which is upstate New York. And the security team there is called RPISec. So over the course of the years, I started getting more and more obsessed with winning these competitions and playing these games. And honestly, I don't think I would be in security today if it hadn't been for CTF. I'm kind of a competitive person by nature. And so in the beginning, I just wanted to win. And so you start playing these competitions and, it's 3 a.m. on a Saturday night and you've got to figure out how RSA works because that's how you get points. Or you've got to figure out where the buffer overflow is in the binary because you want to get points. And so that scene really got me into some of the weird areas of security that really aren't taught in school. So none of this stuff is really taught in school. And so senior year comes around and our team wants to recruit people. And so we had this great idea of creating a class at RPI that just taught hacking material with the express purpose of finding freshmen who we could get into our team to help us win CTF. And that training kind of exploded, and I guess today it's still used by larger companies as training material for security. Yeah, so I love security from that angle. I love doing the hacking stuff, like exploitation, reverse engineering, breaking crypto things. But I really didn't think of it as a job. Sure, you can go do security at the government or something like that, but the fun bits of security, it's harder to find, at least to me it was. So I decided I'd go work at Google. And a month before graduation, a small company in New York who had been talking to through IRC, which is a internet chat system about security stuff, reached out and said, hey, you like CTF, do you want to do this for a full-time job? Come down to New York, we'll pay you what we can. But you could do this for a full-time job. And I'm like, oh, well, this is great. Like, I love the work. It's really cool people. I'd love to do this, for the rest of my life because I love it so much. But I already signed at Google. And so I talked to them a bit more. And I finally got convinced to go down there. So that's how I worked at Google technically for a month and then quit before moving out to California.
Ooh, that must have been a record.
Yeah, the hiring girl for me started crying on the phone.
Oh, no.
I think her bonus was messed up because of that, but I don't know.
Well, Google lost a good employee, I guess.
Oh, thank you. But it wasn't necessarily for a security role at Google. I'm sure they have good security roles, especially with Project Zero now. But at the time I was just going to do regular dev work. And so that happened. And then so since then, I've gotten more and more into security, not just the CTF style security, but other areas of security, which are more research oriented. So a lot of DARPA work. Yeah, and so since then, just as topics come across my path that I get interested in, I start getting really interested in them. My career takes another turn. And so, yeah, and then here we are today. So I founded a company here in New York about 3 years ago now, called Margin Research. We also do a lot more of that security research work. So it's like a lot of the CTF challenges, but applied to research problems or automation issues. So how can we automatically find memory corruption bugs or automatically find misconfigurations in software? So things like that. I think it's kind of a harder problem. So once you understand the problem well enough, the next question is, can you automate it? So that's some of the questions that we ask. Yeah, and then now we're here today.
Very cool. What a fascinating story. So it sounds like you didn't really plan for it. You just fell into the right people.
Yeah, most of my career is like that, where it's just like, all right, I'm strapped into the roller coaster. We're just gonna go.
Very cool. I mean, when you have the interest, when you have the skills, right, then opportunities show up to you, and so you just kind of follow it. Well, what was the company that you came to work for? That took you away from Google?
Oh, it's a company called Trail of Bits.
I've heard of it.
Mike's definitely heard of it. And they actually have a great internship program, which I was a part of as well, over the summer, but then also the program they have is in the winter, which I find really cool, because most students have like a month off between semesters.
Mm-hmm.
And so they'll take students in who are just interested in subjects, but might not necessarily have the skills. And what happens is a lot of people I've talked to, they're really smart kids. They love the subject. They know nothing about it. They just think it's cool. But it turns out when you have the mindset for it and the drive, and you just apply yourself to the problem, you'll figure it out. Mm-hmm. And so they've helped get a lot of kids into security, I think.
That's interesting. Can you talk a little bit about that mindset? Like, what is the cybersecurity hacker mindset that you're describing?
Well, the mindset I'm describing, I don't know, it's not necessarily just for security, but it's the mindset of, or I'm going to figure this out. I'm going to pick apart every piece of this puzzle until I can own the whole thing, until I can, do whatever I need to do, understand it fully. So you'll see this a lot with like reverse engineering challenges where, it might be a huge daunting program. You're just going to sit down and start and pick your way through it. And as you just apply yourself to it, you'll start figuring it out. And so it does require the element of drive and also not being afraid to really go into something not knowing what you're doing, which happens all the time in security, right? So every other week, a new security, as software changes, so does security vulnerabilities. So every week you'll see a new security vulnerability across your path, or a new type of program you have to look at, or a new system that has problems. And so some of the best security people I know, no matter what system you stick them on, they'll figure it out. So it's one of those, you're not necessarily a specialist in Active Directory or networking. You just have that mindset of, I know I'm good at picking apart systems, so I'm starting from ground zero and then pick this apart.
That's interesting. So you're almost saying that, if I may summarize a little bit, like you have to have a base level of skill sets. You have to know how certain tools work, but you also have to have this mindset of just enough arrogance to think that you can make it work, but not too much arrogance that you don't even try.
Yep. No, exactly. I find that, like, in general, if you come in with very good systems programming skills, so if you know how to program in C, you know how memory works, you generally have that mindset of, okay, know how systems talk to each other in an abstract way, you'll go pretty far. So a lot of good security people are electrical engineers, computer scientists. And then, of course, you get the geniuses who come out of high school and just great at things. But
who might you be referring to?
I know you might be a favorite.
Well, that's fascinating. So, can you talk a little bit about some of the skill sets? You mentioned like systems programming. Like what is your tool bag? Like, let's say you are dropped into a system you've never heard of before. and what are the things that you do? Like you don't know what is what, but you have to orient yourself very quickly.
Well, it really depends on what type of system. So you will get people who specialize in doing like web security work, for example. In that case, you might want to know how to use Burp, Wireshark. There's a bunch of different tools to look at like asset management that a company might have. So like DNS dumpster, asset discovery, like a lot of tools like that. And then if you're on the other end of the spectrum and doing things just like, you know, a binary program and trying to find bugs in that, you might use Binary Ninja, Ghidra, IDA to reverse engineer a program. Let's see. And then in general, Python's always popular with people as well.
Yeah, for some reason, Python's become the programming language of choice for anything hacking. I don't know how that happened.
It used to be Perl. It used to be Perl.
That was a while ago.
Yeah, I guess that was a while ago. Oh my gosh. Yeah, I got into it, Perl was the old school thing still.
Mm-hmm. You still occasionally see things show up in Perl. I mean, when I started hacking, like Python wasn't a thing. Like it was about
something.
It's what?
Like early 2000s. That first decade was Perl for.
Yeah, so like early 2000s, even mid 2000s, probably up until 2006 or so, Perl was really the go-to language for anything hacking, which is because it was so malleable, it was so expressive, and it was an absolute entire mess of things when you finish writing it. But Python sort of cleaned it up and made it nicer, and so everyone starts using it for some reason. Like it's just a much more beautiful language, I think.
Bash are also pretty useful too. Like
which one?
Like Bash skills. So you'll get guys who are just really good, like systems IT sort of work, where like you're managing like corporate accounts for, you know, Linux systems and things. So you'll have to be really good at understanding, you know, how an operating system segregates roles and permissions and things. Like those skills come in handy too. Because honestly, it's like any bit of knowledge you can gain about computers at all, at some point will help you with security things.
Also, that's actually fascinating. I mean, ideally you want to know everything, but you know, the mind is only so big. Like, how do you, what is your criteria of choice? Like, how do you look at a piece of technology and go like, oh, okay, this will be useful for me. Maybe it's not going to be useful for me.
I don't really, it kind of comes, like as new things come up, I'll search out information that I need, or I'll just remember reading about something that I had read about or had used in the past. So I'll have the weirdest things come up where I'm doing something, I'm like, this random CTF challenge from a year ago literally applies to this somehow.
That's fascinating. So you kind of have to know, or have tried everything. Like you would have had to try Java at some point. You would have had to try Erlang at some point, because you never know when you might be looking at telco system and it's written in Erlang.
Yeah, I think in general, like people who are very good at security are constantly consuming new information. So it doesn't mean you always have to be working all the time. It's just, you know, it tends to be their hobby as well, where, you know, in their free time, they're programming something or looking at a new cool language or watching C++ con videos, you know, like.
Those are pretty awesome, by the way.
They are very good. I have been known to watch a few.
Yeah.
But like, there's a strong crossover with the low level, like memory manipulation knowledge and the people who do high frequency programming. Because I'm in New York, so there's a lot of financial firms that are interested in that subject. And so you have guys who are specialists, like knowing how the memory works, the CPU pipeline, what assembly instructions add a cycle to your time. And that knowledge, you know, not directly applicable, is still useful for things like maybe exploitation or reverse engineering.
Definitely for reverse engineering. I mean, if you know how assembly works, if you know how the platform works, you can pick it apart, and you know, no matter what your context is.
Yeah, it's like the trust but verify. Like you're always going to go through and test things.
Interesting. Well, how much time do you spend on CTFs?
It comes in waves. Too much, though. That's the correct answer. I mean, last year, because of the quarantine, especially in the beginning of the year, I played like every week. There's at least like 3 CTFs
Oh,
of
wow.
varying degrees of quality, by the way.
Okay, so you're very dedicated.
Yeah, I mean, I still play a lot of CTF. That's how I got into it. I like the competition.
Mm-hmm. Well, which CTFs do you prefer?
So there's different styles, but I like the Jeopardy style CTF the most, mostly because I love the reverse engineering, the crypto challenges. Sometimes the forensics ones be good. Exploitation are usually decent as well, but I like them because they segment out the challenges by topic. And so you're like, I'm feeling like reverse engineering today. Or I'm just feeling like marking up structures tonight. Like,
So you kind of pick like a topic that you might want to practice, or you just haven't practiced in a while, and so you pick on that and you just say, I'm going to solve a bunch of challenges there.
Mm-hmm.
And do you play as part of a team, or do you play by yourself?
Yep, still part of a team. You can play by yourself, of course, but it's always more fun when you have other people to complain to.
I thought you'd say collaborate. Right?
Nope, just play. But you can learn a lot of things from these communities and challenges and stuff. War games are also really good though too. I don't know if you've looked at some war games in your class.
No.
Like punable.kr, reversing.tw, I think it's called. There's a team in Korea who's made all these war game challenges. And they're very high quality, kind of start to finish. A war game is actually how I started learning exploitation. It was back in college, I'd play micro corruption.
Oh, that's right. Very cool.
Which actually I recommend students, if they feel like they're newbies at exploitation, I'd say go through micro corruption, because that's really how I learned. And that one was run by a company here in New York called Monsanto. And they got purchased by NCC Group, not by you. But
all consolidates eventually.
Yeah. But that one's neat because you don't really go in knowing much. And so after, like challenge 3, I was like, wow, guys, I found this new technique where like I take addresses and I jump to the end of a function and just execute instructions that I need. And you're like, that's just called ROP and it's already been discovered. But it really helps bridge the gap between theory and hands-on, which in security, hands-on is the way to go, because oftentimes you can fully understand the theory without having that intuition for hands-on, which you'll need when you come across new problems or the same problem but wrapped up a little differently.
Interesting. So this micro corruption thing, like is it a Jeopardy style CTF? Like how does it work?
It's individual, so it's a war game, so individuals play it, and it's sequences of challenges that unlock the next level. So you'll solve challenge 1, it'll unlock the next one, so forth. And it goes from easy to hard. So it kind of builds things up and you're trying to save the world from a nuclear fallout or something.
Nuclear fallout, really?
Something like that.
Oh boy.
We're causing one. It was one of those too. There was nukes.
But is it? You said it was pretty good for beginners. Like, is it scaled up pretty well? Like you kind of work your way up before you get to the hard mitigations.
Yeah. It teaches individual exploitation concepts very well. So like each level really isolates one concept out. So you don't feel like you're trying to juggle too many things at once. It's also in MIPS, which tricks a lot of people, I think, but electrical engineers know MIPS first. So
why is that?
Old school engineering. Like that's how schools have taught it for like 50 years and no one wants to change. So
that's hilarious. I think my first assembly was MIPS. I didn't understand it then.
Usually people's first. I think the universities are kind of behind with languages. I mean, ARM's the future. Don't get me wrong, but at least start with x86 or something.
I find ARM to be easier to reverse after you've done some reversing, but x86 is easier to start with. Like it was meant to be readable. Do you think it's kind of like that?
Well, the problem with x86 is it's more stack. They use the stack more, and so depending on the program, I think it can be cleaner or not. And ARM, I don't know. I mean, That's a really good question, because I think x86 is easier to read than MIPS. Because at least you don't have the weird, like, delayed slot stuff. But I never had the chance to really look at ARM for a while.
Yeah. You should jump in. It's fun. ARM is fun.
Oh, no, I'm saying when I started, I didn't. Like,
oh, when you started, okay.
Yeah. That is actually, there's something to be said about that, because I find CTF challenges focus a lot on x86 Unix systems, like Linux. And so you won't really find Windows challenges, or OS X, or even mobile, really. Which is one failing of CTF, I think. They kind of got this, the scene around CTF got pigeonholed into Linux.
Oh, interesting. Is it just because it's easier to kind of exist in that space, like it's already an open source world?
I think so, yeah. And a lot of people who create the challenges might do Linux stuff all day or something.
Yeah. Yeah, because like, for example, for our class, one of the things we do is we'll turn off some mitigations and say, okay, well, like, this is a non-ASLR system, try to hack it. Not because we will never solve ASLR challenges, but because, you kind of want to progress your way up.
Progress your way up, yeah.
Exactly, yeah. You don't want to just jump in and solve all of the big problems. But I don't know if you can do that in Windows per se. It's been a while since I've looked at it. Like, can you disable mitigations?
You probably have to download like XP or something and run it in a VM.
Yeah, that's
no one wants to do that. So yeah.
I think about 10 years ago, I remember I was looking at training or taking some training, and they would use Windows XP systems. And I thought 10 years ago, that was pretty late in the game to use XP for exploitation training.
Yeah. I mean, though, people still use it. Like, if you work at a large company, they still have XP boxes up.
That's terrifying.
That being said, they have servers still running on the internet that they forgot about. So
that's absolutely terrifying. I did hear of FAA using Windows 3.1, but it was strictly separated from the rest of the world.
Was it though?
I hope so. that's my default.
Don't worry. It's on a different internet. You're like, but there's only one internet. They're like, oh.
Yeah, never mind. Although, to be fair, Windows 3.1 is probably the most secure Windows out there. It doesn't really have a network stack, so can't get to it.
It's like those jokes about Temple OS. You can't have a privilege escalation if everything's running in ring 0.
Now we're getting somewhere.
Exactly. That's how you solve security problems.
I mean, maybe a little too much digression. I remember looking at Temple OS, and there was something really fascinating where you could break the system at any point, write any amount of C code, and we'll just kind of compile it in and run it for you. Is that true?
Yep.
That sounds like it. Okay.
The feature to someone.
I mean, you technically could do that with Softice back back when Softice was a thing.
Mm-hmm.
So I guess maybe that's a legitimate feature.
Yeah, no, I think it was. I mean, I don't know if anyone who legitimately used Temple OS, but
I think you'd have to have a pretty special use case for it.
Yeah.
So so you had some demos for us. You were going to show some challenges.
Oh yeah, so you can go through some of these. And it's kind of a side note. So I'll be showing Binary Ninja's interface, which I guess you guys have already seen a little bit of. So a lot of my work, when I talk about automation and things, has been able to use the Binary Ninja API to automate that. And it's kind of a subset of security called program analysis. And the idea is, can we kind of automatically go through the program looking for specific patterns that we might want to know about. And we can do this when we look at the different intermediate languages of binary. So I will share my screen first. Okay, so this is just a kind of simple program that has a bunch of buffer overflows in it, and a bunch that aren't exploitable. So for example, memcopy check, we know we can't exploit that one. Actually, this one was compiled in OSX. Ignore that. So compilers have gotten a lot smarter over the years. And so for OSX, for example, Clang will add memcopy check in when you use memcopy. If you're copying to a stack buffer, to check the length of the write to that buffer, so there's no overflow. So avoid that one. Should apply that in Linux.
So we want the vulnerable one instead.
Exactly, yeah.
And is this a CTF challenge, or where is this?
So this is just a small example that I made for a training class that I do on program analysis. So we'll start by just looking at this main function. All right, so this function has two memcopies. You know, we can look at, let's see, we'll do high level save form first. There we go. All right, two memcopies. We want to know if we can write something larger to a stack buffer than the actual size. So in both cases, we have these stack buffers. We have kind of input data, and we also have the size parameter. Now we can visually see that the size parameter is checked before this first memcopy here, but it is not checked above the second memcopy here. And so of course we can just read the code and note that, oh, hey, the second memcopy, we can do a stack buffer overflow because this parameter, the size, can be greater than the stack buffer because it's unchecked. So there's no check to look at the size. However, if this program was much larger, so let's say we're looking at, you know, more of a real world program where, you know, this would be nested in tons and tons of code. We might not want to have to reverse engineer everything if we know exactly what we're looking for. So we can write a program to check this program for certain patterns that will tell us something about potential buffer overflows. Okay, so first thing, I guess, well, the first two things we'll look for are kind of two things. So we want to find the buffer size that we're writing to. So what's the size of that stack buffer? And what's the potential size of this, or what's the potential values of the size parameter? And of course, we don't know what the potential size could be from our input because we can input anything. But we'll want to check to see if there's any bounds or put upper limits to what that number could be. So in this example, this would be, you know, 0 to max integer, and then this memcopy would be 0 to 0x3f as a potential size parameter. So we want to be able to write a program that goes through the entire test GCC program, which is just the name of this binary, finds all the memcopy sites, checks to see if it's writing to a stack buffer. If it is, we want to see what the stack buffer size is and what are the bounds on the size parameter to the memcopy. And again, this allows us to automate our understanding of what a memcopy or what a buffer overflow is, and then check for it on very large code bases. So we don't have to sit and reverse engineer everything out. And I guess we'll usually have people follow along, but I'll just kind of go through what I have. Let me actually share everything here. Okay. I hate the new OSX. It's terrible, don't upgrade.
Oh, no.
No. Sorry, Mike. It's so hard to find the like do not disturb.
That went straight into my heart.
Okay, so well, first
maybe there's a way to make that bigger because it's kind of.
Yeah, I'll make it bigger. I just want to pull up the.
Okay.
Let me see. There we go. So this is the original program. And I can give this to Mike if you guys want to play around with it or something. But I compiled it with a bunch of flakes to make it less protected. or less optimized. But we can see here that we have our two mem copies. We have one mem copy protected through this check from the number of bytes check. We have this second mem copy not protected. And we also have our stack buffers, other buff and buff up here, which have a specific set size. And so we should be able to pull that out as well.
No, I think I saw in the binary ninja output, it didn't actually say the size of those buffers.
Yeah, so binary ninja won't, so this is a kind of a spiritual argument about decompilers at this point.
Spiritual.
So the issue with stack buffer sizes is like things like binary ninja or IDA, they don't want to calculate that size for us necessarily, because what compilers will do is you might have a stack structure that's on the stack, and different references or offsets, references to offsets in that structure will be used in the program or in that function. And so what will happen is you'll actually just get two variables like var 54 and var 94, even though in the original source code, they were both part of the same structure. And so in this case, both of these are of size 64 bytes. But I could rewrite this to be a structure of two char buffers of the same size. And so technically I might be trying to find my object that's 128 bytes large. But the program is compiled in such a way with optimizations and things that it looks like there's two separate variables of size 64. So that kind of side caveat doesn't really apply to this program. But when you're looking at larger programs with lots of structures in them, you would get a lot of issues there if it doesn't show, or if it would try and show too much information. Yeah, so what binary ninja can tell us is there's a reference to a stack buffer here called var 94. It doesn't know its size. And so it's up to us to calculate the size. And what we'll do is kind of an easy solution, which is just take a reference to the stack, find the next reference that's used in the function and subtract the two. And that'll be our size for our buffer. But again, that might not always be correct if they're stack structures. You can see the terrible naming conventions for my folders. All right, so I'll walk through some of the solution. A lot of this is kind of wrapper code that you need to work with binary ninja. Let's see. Okay. So we'll start at the beginning. Let me see. This is all wrapper code. All right. So we'll start off and say, where's the mem copy? I like to refer to this method as kind of finding the sync function. So you have sources and sinks. And in program analysis, a sync function is just what's that starting point of where the vulnerability might be. So where the overflow might happen, where memory corruption might occur, that sort of thing. So that's our sync. That'll be at the mem copy. And then if we want to put the work in, we could try and trace that sync back up to the source, which would be our input. And that I find is a little bit, well, it's a bit more of an elegant solution to finding vulnerable code paths than doing it the other way. But that's just a personal preference. All right, so we find all our mem copies. So it turns out there's two of them in the program, so that makes sense. We get all those mem copies. And then for each mem copy, I'm going to see this here. We want to check the mem copy size parameter, so that third argument. And we want to check the size of the stack buffer. And then once we have those two pieces of information, we can see it, we can write some sort of checker to determine if something's vulnerable or not.
So even though binary ninja doesn't show the stack buffer sizes, it in the API it knows what they might be?
Well, no, so it says, okay, I have all these stack references, and then it's up to you to do the subtraction. Binary Ninja could do that, they just don't. But I guess that's more of just a use case sort of thing, so. Let's see. All right, so this one is looking at stack size, buffer size. Let's see. We'll go to this one second. Actually, I do the checking here as well. Okay, so Binary Ninja is pretty awesome because they do a lot of kind of the program analysis bits for us. And so what the API will provide is a set of possible values for a parameter. So we get to this mem copy, we say, okay, we care about the size parameter, which is this third argument. And we want to know what possible values that variable could be based on the checks in the function. So once again, in this case, nothing can be greater than 0x64, and nothing can be greater than 0x3f if we want to hit this first mem copy. And then nothing can be greater than 0x64 for this one. And that's it. And so before Binary Ninja, what you'd actually have to do is start at this variable and try and find every conditional branch in the code that affected your path to get to that sync, to calculate yourself what the constraints on that variable were, using tools like Z3 or something. Very intensive process. Sometimes you still have to do that, but Binary Ninja's API is pretty decent, and it provides you with some of that information. And down here for the stack buffer, we can do something similar and look at the stack frame offset. So they just have a type for stack references, so it's called stack frame offset. And we try and find the next possible one used and do subtraction. And then of course, what we're doing after this is just doing a check to see, okay, if the stack buffer is this size and the mem copy size that we got from above is of a certain value, check to see if it's vulnerable or not. So I kind of massage that into the same function, but it has that feature. So let me run it quick because I know it kind of looks a little messy. If it's headless version of this. Yep.
Now, unless I missed something, in this solution, you're not using Z3 to analyze.
No, we don't have to because of the Binary Ninja API, which provides us with a get possible value set, which gives us that range,
I see.
which we would have had to use Z3 to calculate if it didn't apply, or if it didn't provide us with that.
Do you know how they do it in the backend to calculate?
I forgot the term of what they do, but they basically do what we would have to do, which is collect all conditional statements applied to that variable. And they actually use SSA form as well, which is what we would use.
What's the SSA form?
Side note, but yeah, so SSA form looks a little cleaner here, is gold, first of all, because before SSA form, it was a lot worse. Sorry,
Well, that's a good enough description. SSA form is gold. We're going with that.
That's a tweet right there. Because when I first started getting into program analysis, it was LLVM for source code. And that was amazing because LLVM, which is part of the Clang compiler, has all the features you could want. It's a very interactive compiler toolkit. But of course, you don't always have source code. And so in that case, you would have to script things up in just the worst possible ways. I remember I saw, oh gosh, I don't know if it was, I've never used the IDA Python, by the way, never touched it. Don't play.
Never have, that's impressive.
No, it's impressive if you can use it.
It's not so bad. You can do the fancy things you're doing here though. I mean,
yeah,
it's pretty rudimentary in comparison.
I think before I was pulling out constraints using like objdump and stuff, there really wasn't any great program analysis tooling for binaries. At Trilobits, they had something called Mixema, which tried to lift the binary into LLVM-IR. So you could use Clang's LLVM on the binary, which kind of worked. You could, of course, use IDAs, and that was really the only two options that people used. And then after Binary Ninja came out, the one thing that they did, which no other tool really has done before, is lifted a binary to an intermediate representation with functionality that is very close to LLVM, which is cool. So yeah, SSA form, it stands for single static assignment, and all it means is that it splits variables up such that every variable that's used in the intermediate language has been assigned once and can be used multiple times. So this is useful for us if we want to say, okay, I have a variable at this basic block in this branch of a function. I'm trying to figure out the value of that variable. So what you could do is say, okay, where was this SSA variable assigned? In Binary Ninja, it's like, oh, okay, it was right here. And you know that is 100% the only spot that it was ever assigned.
Very cool.
Which is cool. I mean, you have the issue with like pass by reference and stuff, but that's only applicable to stack parameters now, and they don't treat stack memory cells as SSA variables. So that's a side note. The other issue too is
if you have a variable on the stack and they're assigning to the same address, it's not going to use it as an SSA variable.
Right. Yeah. I mean, a reference to the stack can be an SSA variable, but like the stack itself can't be an SSA variable or a memory cell in the stack. You have a similar issue with heap analysis. So if your variable is a pointer, that can be an SSA variable because it was assigned once, it was assigned through malloc or something. But then of course that memory gets, dereferenced and written to and all these things. And that is not tracked. So you'd have to have separate analysis that tracks the values in the heap. That's a whole separate problem as well. Yeah, so in this case, we have SSA variables here. So it was assigned once when you just walk up the assignments to here. Okay, that's argc, that's our input we control it. So it's unbounded at this point. Walk through, and now we start seeing these constraints being applied to it. And so here it's undetermined, but here we have assigned range value. And I know it's not the easiest to see. I can't enlarge the pop-up.
I can see the little pop-up giving you those answers that the API would as well.
Yeah, and so this is just a visual of what the API can provide us. And they can do this because of SSA form. And they're saying, okay, so in order to get to this basic block here, this variable has to pass this check. And so we know at most it has a max bound. Now it's pretty cool because if we trace this variable to a use, let's say this variable here was used in this basic block, it would still be undetermined or undefined because it clearly didn't pass this check. Oh, it might have a lower bound in that case. So the possible values of an SSA variable can change if you're depending on which branch you're in or which basic block you're in.
Right.
And so by the time we get down to this mem copy, we have that signed range value. That's correct.
So this is kind of like cheating, isn't it? Like it does all of the work for you of reverse engineering.
A little bit, yeah. I mean, but like I said, before this, you'd have to do a ton more coding. There's some cases where it's not perfect, but for the most part, the Binary Ninja API for this stuff is very good at just incorporating constraints in branches. So we call these guards. And so in order to get to this basic block, this check has to pass. And so it knows something about this variable. So we can see here that var 95 now has a new signed range value of -80 to 3f.
Very cool.
So forth.
So using that range, you now can figure out whether or not that fits within the variable you're actually copying it to.
Yep, so now we have this range from the SSA variable, and we know the buffer size through our stack offset calculations. And we can just do a simple comparison.
Very cool.
And so it's pretty nice to find on copies. You can also do pretty easily find other types of bugs like format string bugs. I don't know if you guys have talked about those, or command injection. So let's say you control the input to a system command, things like that. And again, you'd have a very similar technique where you find the function that you care about. So that's either system, memcopy, printf, and have some logic around the constraints or the possible values of the parameters to that function. And once you can abstract those constraints out, you can look for that pattern in any program. So it's kind of like magic. Just putting that
it does feel like magic. I mean, this you can basically run on all of your code before you release it. So
exactly,
almost like a unit test.
Yeah, it can be kind of like a linter or something as well, where you're looking for these patterns. It's almost like a more intelligent linter, where instead of looking for, textual issues, you'll find things that might be introduced at the compiler level, or like when macros are compiled in, for example.
That makes sense. I'm excited to see how well it runs.
I know, like it better work.
Have we done enough praying to the demo gods?
No, clearly not. Let me see if I put it in the plugin. Oh, here we go. Let's see. And we can also write plugins that get used in. There we go. It's not running it. Maybe I have to move it into the plugin folder. So Binary Ninja has this plugin system where, if you put Python scripts in this plugin folder, it'll load them into your Binary Ninja API.
Automatically.
Automatically, yeah. Let's see. And let's see. Oh, I wanted to ask any questions, but no one else is.
I mean, this is just me. I'll drop in questions once in a while. And if you want, I can proxy questions after we publish this to the students. Okay,
yeah, definitely. If anyone wants anything answered. Let's see what I named it. I have one more point for this. Let's see what issues they had.
This is like a live debugging session, quite exciting.
Yeah, now you can see how it's doing. There we go. This one is called, oh, it's day 4. That's what happens when you have too many scripts in one folder.
One thing I've done in the past is use Binary Ninja API through a Python notebook. And it came out pretty awesome because you could iterate very fast with your analysis. I was wondering if you did that before as well, or maybe a similar process.
I usually use headless, so I usually run it just as a separate program. Well, let me try one more time and see if it works. Let's see. Let's see. API does change every once in a while too. Just so. Let's see.
You should get Jordan in here and be like, dude, why
I
didn't
know
you change
live
the
reels
API?
working. Oh, okay. Let's see. There's a new API thing for this. We can look at other code at the same time. There we go. This is what a larger program looks like for Binary Ninja. There we go. It's
Quite confusing.
file.
How long have you been using Binary Ninja? Is this your go-to tool?
Gosh, 4 years now, maybe. It's definitely my go-to tool. There's really not many other options. I keep saying that, I know, but
I mean, there's 2 other options I was going to mention, but maybe I shouldn't.
like which ones?
Well, like Ghidra or IDA Pro. I mean, these 3 tools
Excellent.
tend to compete with each other. Well, like, what do you think about them?
Well, okay, the thing with Ghidra is it doesn't have, there we go.
Working. Woohoo!
This is why it's like at a certain point, instead of Googling something for Stack Overflow, I just look at other files that I wrote.
I definitely do that a
Like
lot.
weeks ago, yeah. In my own Stack Overflow. That's how you know you've made it.
When you're indexing your own code to see how you've done it.
Yeah. Like, wow, this person's so smart. Oh,
The struggles are hidden away in the past. That's what happens.
Yep. Yep. It was so traumatizing, just black boxed it.
Yep.
Let's see. Yep. So we're looking at the different possible values for this one. We pull out ranges. This is actually a really good example. So in this case, it found every memcopy vulnerable. And we're like, okay, well, why is that? Because we clearly went through and found one that was guarded by this 3F, and we don't see that showing up here. This is one of my pet peeves with Binary Ninja. So the issue here is what happens is there's a sign extension. And this happens because we're on a 64-bit system. So a compiler has sign extension. Now at this point, the value is undetermined for the constraints. And so Binary Ninja defaults back to what the original range was. I don't have a good explanation of why we get a range at all here. I do know that we're losing the extra detail from this check because of the sign extension. And that's just kind of a bug in their analysis where they don't really know exactly how to handle that sign extension. I think one of the problems there is sign extensions or zero extensions can cause lots of different side effects depending on the architecture to the integer value.
So they just kind of have to account for it in their analysis.
Right. And so I think what Binary Ninja is trying to do is say, okay, well, in a perfect system, we can't say one way or another whether or not this variable is affected, so we won't. Whereas from my perspective, I'm like, okay, 99.9% of the time, we can just knock that out. We don't have to worry about it, and we can still propagate forward that constraint. So they're trying to be, more perfect, so more people can rely on their code to be 100% correct. Whereas from a security perspective, we're writing program analysis passive, we want to say, okay, well, give us an over approximation, like this is generally true, so we can run with it. And then go back manually and look through for false positives. But yeah, so we can see here that this was properly bounded, and then we lose that bound here. So that's a neat example of that. All right, so that's buffer overflow stuff. We can still run this on a more complicated example, which is just larger and also interfunction. So I know we're kind of running up on time, but I'll toss this
We
one.
got plenty of time.
So in this example, we have memcopy and trivially broken, where we have to trace back up to the function called the call site of that function. to actually find the variables we need to get useful information about a memcopy. So it's basically the same example as test GCC, except now we're going, instead of just walking up basic blocks, we're going to try and walk up function calls to determine variables, bounds, that sort of thing.
Mhm. How like what is the size limit of a program you found this technique to be valid on?
Well, the iOS kernel cache currently doesn't load.
Too big.
Too big.
Now that's about 180 megabytes of code.
Yep.
That's a lot of code.
A lot of code.
Is that binary ninja that's breaking on it, or is it this analysis that's breaking on it?
Yeah, so when you load a program in Binary Ninja, it doesn't only just disassemble, it also runs all of its analyses. So it can expose these APIs to you. And so you get some like time issues there.
You know, I did recently try to load the shared cache in IDA Pro. I think it's been day 5 that it's been running.
That's usually like a 3-day one. That's surprising.
A 3-day one? Well, I also close my laptop, you know. It's
Oh, you can't close the laptop. You gotta keep it open.
yeah. Otherwise it overheats.
Oh, well, that's a different problem. That's the trick with IDA. If you close all the tabs while it's loading a binary, it loads faster.
Really?
Don't know
Okay.
why. It turns out that if the tabs are open, there's some logic inside of IDA that tries to continuously update the visuals for you. And it
How wonderful.
prioritizes that over loading the binary. So it's a little.
There should be a form that says don't update the UI until this is done.
Yeah, you'd think so, but no,
Yeah.
there isn't. No, that's too much to ask. You know, security engineers are not known for being great UX developers.
I had not noticed that at all.
Let's see. One other cool thing that we come across a lot at work is just weird architectures as well. So if you're looking at firmware from you know, weird IoT device or a weird system, you might come across different types of architectures that aren't supported by default, and Binary Ninja makes it very easy, though Ghidra does as well, to make architecture extensions and load things. So I won't go too much into that, but it's also a different possibility.
Yeah, very cool. But do you use Ghidra at all, or you prefer? You just know this tool? And
well, you know, my Mac didn't come with Java, so that means Apple doesn't want me.
That's not my fault.
I don't know. Ghidra requires Java. I don't have it. I don't see how that could be fixed.
I think you have a very legitimate reason not to use Ghidra at this point.
Thank you. I love it. I knew someone at Apple, they loved Steve Jobs so much. They're like, well, if he didn't want me to have Java on my laptop, I won't install Java. And it turns out our signals and systems homework required Java. And so he just failed that class. Because
well, you know, they did also pioneer no Flash anywhere. So that's a pretty good thing.
That's true.
A pretty good side effect of the same.
Yeah, no Java, no Flash. Turns out if you just remove, they're going to remove Python too.
Yep.
Yeah.
If you remove your attack surface, it's not there. You can attack what's not there.
Yeah.
Cool. Well, I think it's probably a good time to wrap up. And I was wondering if I could ask you one more question to help some of the students in this class. And that's, what advice would you give to someone trying to break into the field or to find a niche if they're already in there?
Well, I think the finding the niche thing, for example, like I think just keep trying out new things. So like I do a lot of program analysis stuff now. If you had asked me 5 years ago what that was, I would have didn't know. Like, so just kind of as things come across your path, try them out. That's one reason I still play CTF is, you know, I just come across new things a lot or new ways to solve problems. There's other things like that though too. So just kind of keep being inquisitive about different things. Technology changes so quick that you really need to stay on top of it. And in terms of breaking into security, I think you have to find something you really enjoy doing or love doing in security and focus on that. And that'll help a lot with having that drive that you need to really, tackle problems, but never get intimidated about problems that you don't know anything about, because chances are most people don't know about that either. And if you can't Google for the
Way of saying
solution,
it.
then you know you're in the right spot, because that's the real cool work there.
Cool. Well, I think that's a really valuable advice. Thank you for being here, and I really enjoyed the demo.
Awesome. Yeah. Well, I hope to see you in New York soon.